In today's video, let's focus on one tail test or one tail test. The previous video we were focusing on the two tailed test. So if you didn't see it, here is the description. We will describe it here, we will post it here, then follow it so that you may understand better before you continue with this one of the one tail test. So the first question that we are given in a one-tail test hypothesis is: a manufacturer of a detergent claims that the contents of boxes sold weigh on average at least 16 ounces. The distribution of weight is known to be normal, with a standard deviation of 0.4 ounces. A random sample of 16 boxes yielded as a sample mean weight of 15.84 ounces. Test at the significant level, the null hypothesis that the population mean weight is at least 16 ounces. So in this information, for us to see that we are dealing with one tail test, from this statement we said that the average on our average is at least 16. Wherever you see at least or at most or less than or greater than, you know that you are dealing with one tail test. From there, they said that we must test at the 10% significance level, the null hypothesis that the population mean weight is at least 16 ounces. Is it true that our weight is at least 16 ounces? So first we have to test it, whether this null hypothesis is acceptable or not. So here we wrote our null hypothesis. Our null hypothesis, we are given that is at least 16. Here it is, but you denote it by this sign greater than equals to 16. From there, our alternative, don't forget that alternative is the opposite of null hypothesis. From there, our alternative, it will be less than mu is less than 16, or the population mean is less than 16. We are given that our standard deviation is 0.4 and our sample is 16. Finally, our sample mean is 15.84. From there, we substitute this into this formula to the precise values that are matching here. From there, after that, our answer, we got minus 1.6. This is the statistical value. Our statistical value is negative 1.6. Therefore, this is not the final answer, because we have to make sure that we get the statistical value and the critical value. That critical value, the statistical value and the critical value, they will tell you whether the null hypothesis is to be accepted or rejected. So we are given that we must test this null hypothesis at the 10% significance level. The 10% significance level, it is here, 0.1. This is what we call the, from this side, it is one-sided. It is greater than, at least, or less than. From there, we are going to focus on this part. From there, we are given that is at 0.1%. I mean 10%, which is 0.1. From there, you know that you are going to say 0.5 subtract 0.1, you will get 0.4. From there, you go to your table, you check 0.4, where it is 0.4. From there, at 0.4, you will be able to get that, no, my 0.4, the respective, the z values are 1.29. Since here it is the negative side, we include this negative part. It is negative 1.29. From there, we're given that our critical value is 1.29. From there, you know that you have 1,29 and 1,6. Therefore, you will confirm, where does my statistical value lie? It lie in the rejection part or the acceptance part. Where we shade is where we reject. Where we don't shade is where we do not reject. It is the acceptance part. Since we know that our 1,6, it will be somewhere in this part, somewhere in this shaded part. Therefore we can say we reject the null hypothesis because it lies in rejection region. It is here. From there, statistically, we can say that there is a strong statistical evidence that it is not true that the mean weight is at least 16 ounces. Let's continue to the second question. If you don't know how to find the critical value, I've created a video where tutoring how to find the critical value. From there, you will also see it on the description on the screen. From there, let's continue the second question. A random sample of 172 marketing students was asked to rate on a scale from 1, which is not important, to 5, which is extremely important, health benefit as a job characteristic. The sample mean rating was 3,31 and the standard deviation was 0,70. Test at the 1% significance level the null hypothesis that the population mean rating is at most against the alternative that it is bigger than 3,0. This one also, we know that we are given that wherever you see at least or at most, you know that it is one tail test. Might be the upper tail or the lower tail. The upper tail or the lower tail. From there, let's continue with it. Here we wrote our at most 3,0. Our alternative was greater than 3,0. Here we are given this statement. From there, we wrote each and everything that we are given, which are going to use. From there, we wrote this formula, then we substituted the values. From there, our statistical value, it is 5,81. From there, we must go to find the critical value. Our critical value, we found it to be 2,33. Again, if you don't know how to find the critical value, check this video here at this description. You will be able to see how we find the critical values. From there, since we found our critical value to be 2,33 and our statistical value to be 5,88, we know that automatically 5,8 is greater than 2,3. That means 5,8 is going to lie somewhere into this shaded part. And don't forget that the shaded part, it is the rejection part. It is the part that we are going to reject. We reject the alternative hypothesis because it lies in the rejection region. From there, statistically, we continue that we have the evidence that the population mean rating is at most 3,0. 3,0. We have that statistically that the population mean rating is at most 3,0. Here we concluded everything. We concluded everything. Thank you very much. I believe this video helped us a lot. If you didn't understand, feel free to leave your question in the comment section. We'll attend to it.